What I'd like to do here is to show the command line show commands from the routers themselves, and I'm going to start and stop the Calnex tester. So what's going on here? There are a few screens. First of all, there's the PowerPoint screen here, which shows two routers, the Cisco NCS 560s. There's two of them, and then there is the Calnex tester, which is actually a Paragon X tester made by Calnex. This is emulating packet time protocol, which is 1588, IEEE 1588 version 2, and all of this stuff is set up as a telecom profile of G.8275.1, and this is what's used in 4G networks, where you need frequency and phase alignment across all of your network. There are a few requirements in this profile. The profile kind of defines certain things you can do and what you can't do. For example, there's got to be a boundary clock between every node and down to the ordinary clock. So you can't have transparent clocks or anything like that. So I've got to be a boundary clock. And you remember a boundary clock, basically you have this master-slave relationship where the timing is preferred by the master, and the slave recovers the timing, and then the oscillator in this boundary clock becomes as good as the grandmaster, and then he can then, or she can, transfer that onto the downstream router, and the whole thing continues on down the chain. The packet time protocol, there is a thing called the domain, and this I've called this domain, and it's number 24 in this case, and this is how the PTP protocol can communicate across each router. Knows how far it is away from the grandmaster clock and whether there's a failure, and if there is a failure, maybe select a secondary clock or a tertiary clock. Okay, the other interesting thing is with this profile is that you need synchronous Ethernet and PTP. They've got to be together. Sync E will provide the frequency, and PTP provides the phase. Also, interestingly enough, there's no IP. This is all running on Ethernet, and the Ethernet ports are here as shown. This is the 0001 for the Calnex, 24 2B for this interface here. This is 10 gigabit, 0207, 100 gig, and this is the MAC address here, MAC address, MAC address. So this router here is the left-hand screen. I can show PTP interface brief here, and you can see that the interface 0207 is a slave, and it's up, and this is 0207, and it's up. We'll look at the Ethernet address in a minute. The master is on 0100, which is this one here, master. And if I do the same command here for the right hand side router, you can see that 100 is the slave and the 10 gigabit is the master. 100 is the slave and 10 gigabit is the master. Everything's stable, everything's up and running. Now this screen on the right is the user interface for the Calnex tester, which is this chap here. Port 1 and port 2 on the screen, port 1 and port 2 on this screen. The DUT is the device under test, which is these two routers. At the moment I'm running the protocol, the test, with this button here. I can turn it on or off, but for now let's just leave it running, and we'll take a look at a couple of screens. For example, we can take a look at from the perspective of this router, where is the grandmaster. You can type in this command here, and it's showing me that it's connected on 0207, and the address here, the MAC address, is A all zeros 1, which is this chap here. If I do the same command on this router, this one, it's showing me that it's getting its master from this interface 100.0.0.0.1, which is this one, and this MAC address 24.12, so it's getting it from this, that's where the master is sitting. If you look at this, let me just show PTP for a master's brief. Show PTP dataset current, that's what I need. When you type this command in, show PTP dataset current, you get this steps removed 2, and this is referring to the links. This link is 1 and then 2 up to the grandmaster, and it's showing you it's minus 3 nanoseconds offset. Its oscillator is a little bit off. Well, in fact, it's very, very good there. If I do the same command for this one, I can see the steps removed here is 1, because from his perspective this is 1 to there. Okay. We can take a look at synchronous Ethernet as well. So we can type in on here. So let's take a look at this. This is show frequency synchronization. This is for Sync E, and we can see that the 0207, we're receiving primary reference clock. We're using primary reference clock. The priority is 1, which is the highest, and I think it goes down to probably 256 or something like that. And this is like the priority can be used as a tiebreaker. If there's equal paths and stuff, you can make 1, so 10, 20, 30 and so on, and the lower number is the one it will choose. We're sending, the quality level sending is do not use. Okay, so this is 0207. The Calnex is sending a synchronous Ethernet primary reference clock, and we're sending back a do not use. Over here on the right hand side, we can see that on the 0001 we're sending primary reference clock, sorry, we're receiving a primary reference clock from this side here, because we're sending, if you look at this 100.0100, we're sending primary reference clock. Here so this is the interface to this interface 0001, and we're receiving, and we're using that one also. We're sending a do not use. The other interfaces are part of the network, and I'm just keeping it simple on this drawing. Alright, the other interesting thing you can look at is the protocol packets going between each of these, the PTP protocol packets. If I type in PTP packets 10 gigabit, show PTP packet counters 10 gigabit 0207, which is this guy here. So we're looking at this point, looking up at the Calnex. We can see these are the announcements and sync and display requests and so on, and there are some dropped here, which is sometimes you get if I start it up. So let me just redo this again, and you'll see these counters increment 55, 13. So you see that these are incrementing here, and this is a good indication that everything's fine. You see that the 291 that was just a drop. You can clear these counters as well, I can do the same on here as well. Okay, so you can see it's 43, 12, 53, 96. This is incrementing. So what I'm going to do now is have a bit of fun. I'm going to turn off the just before we do that, we need to see whether it's in phase or not. So we look at the servo, and this is phase locked on here. Sorry, I should explain that. Show PTP platform servo, and you can see it's phase locked, which is absolutely brilliant. And they can click on here and do the same again, and we can see that it's phase locked. It can go, that's the best there is. The next one down is frequency locked, which is kind of all right in between for a moment of time. But okay, so let's go to establish a baseline, and we can see at the moment that we have master slave on these ports, slave master on these ports. I'm going to come over here onto the tester. I'm going to turn it off. So PTP is now stopped across here. You'll get a message come up in a moment from this router here. Here we are. It's saying sync fail, synchronous status mesh equality, PTP source has changed to fail. So if I put in this again, the show PTP interface, you can see that from this 100 in port, it's now showing passive. Okay, nothing else has changed, but it's passive. And then if I do the is it phase locked? No, it won't be. We'll have a look. We can see that it's now frequency locked. Okay. And then we have a look at the perspective of this chap. We can see that it's passive, and again this will be frequency locked. The communications between these two PTP communications protocols, because we're running a PTP domain, and we call it 24 there. Okay, let's put that back, turn it back on again. Now PTP is running. So it's showing uncalibrated at the moment. This is showing still, well, this is still passive. This is showing uncalibrated. This is from the 10 gigabit looking back up to the Calnex. It doesn't come back instantly. Eventually this will become established. Maybe look at the servo, and okay, that's very good. So that's might be okay now. No, it's still waiting. There we are, slave now. And now this should have changed. We have a message here saying quality of the service has changed from fail. So I can tell you where it goes to. It just tells you what it failed from. Anyway, click on here, and this is doing the same deal now, where eventually it will go over to master. Sorry, to slave. Okay. That's it for now.